Lesson 10.2 is about real number exponents. So you can see the objective there is to extend the meaning of exponents to include irrational numbers and to define exponential functions. So we'll be doing some simplifying again, as it says, with irrational numbers in the exponents. So maybe like a radical or pi or something like that. And then we'll also solve exponential equations. And you can see the steps here for that. So we're going to express each side of the equation as a power of the same base. And then we can set the exponents equal to each other to solve. So let's get started. First, we're going to start out with a couple examples of just simplifying expressions that have irrational numbers as their exponents. Really, there's no difference here. If you look, from this first example, we're raising a power to a power. When we do that, we multiply our exponents. We know. So what we're going to have here then is 3 to the 2 times root 2. And then I can just simplify that a little bit more because 3 squared is 9. So I can just write this as 9 raised to the square root of 2. We'll try the next one. Same thing here, we're raising a power to a power, so negative pi raised to the negative first power. So if I do that, I'm going to multiply those exponents and get 5 to the positive pi. So not much going on there. You could have thought of this also, negative exponents, bring it to the bottom and make it positive. So we could think of this, first of all, as, oops, let me erase that. Essentially doing like 2 flips. So this first negative pi here can bring it to the bottom and make it positive like this. And then this negative first power means we flip the whole thing again and we just get 5 to the pi over 1, which is just 5 pi. Again, the first way I did it is the most direct way of just multiplying those exponents. All right, here's another example. It's 6 raised to the square root of 2 times 6 square roots 8 over 6 3 root 2. There's a couple different ways you can look at this. You could decide that you want to simplify your numerator first. You can decide to divide first. I'm going to divide first because I see that these both have root 2 as their exponent. So I'm going to go ahead and rewrite this as 6 root 2 over 6 3 root 2 times 6 root 8. These say the same exact thing. So what I'll do is first simplify this division here. Whenever we have like bases, we can subtract exponents. So this is 6 root 2 minus 3 root 2 times 6 root 8. Okay? And so if I do that subtraction, then I get 6 to the negative 2 root 2 times 6 root 8. And then finally, let's just simplify that root 8, because if we break down root 8 is 2 root 2. So we have 6 to the negative 2 root 2 times 6 2 root 2. Again, you could have done that in the beginning if you want. Simplify that root 8 right away. Here then we're going to be adding exponents. So I know negative 2 root 2 plus root 2 is just 0. Anything to the 0 power is 1. So again, a little bit of option there in terms of where you want to start your simplification first. Let's try another one. Not much going on here with this one. We got 25 to the 2.4 and 5 to the 5.8. What I would do first with this one is rewrite 25 as 5 squared. Just get those like bases. So 5 squared to the 2.4 over 5 to the 5.8. So first, if I go ahead and multiply that on the numerator, that's 5 to the 4.8 over 5 to the 5.8. And now, because I'm dividing like bases, I subtract exponents. So that's 5 to the 4.8 minus 5.8, which we just get 5 to the negative first, or 1/5. Okay, let's do a couple examples where we're going to actually solve. My mistake. Those directions should say to solve. Solve for x. That's what we're doing. Now we're solving these exponential equations. Rewrite it under here. Okay, So the goal with this one is to get matching bases. So we have 5 to the x equals the square root of 125. The first thing I'm going to do is use what I learned in lesson 10.1 to rewrite that as 125 to the 1/2 power. Now I want my bases to match. This has a base of 5 here, so I want this to also have a base of 5. So we can rewrite 125 as 5 cubed because they're the same thing. So we rewrite 125 as 5 cubed. And then on the right-hand side, I have 3 times a half there, so I have 5 to the 3/2. So now it's real easy. We have 5 to the x equals 5 to the 3/2. Well, if our bases are equal, then our exponents must be equal as well. So what we can do is just set our exponents equal to each other, and x equals 3/2. And that's essentially the process that we'll use for all of these solving exponential equations. So let's try the next one. Again, we want to have the same base. So I'm thinking, okay, I can rewrite 4 as 2 squared, and I can rewrite 8 as 2 cubed, and then they'll both have a base of 2. So let's do that. 4 is 2 squared. 8 is 2 cubed. Now be a little bit careful here. We're going to have to multiply 2 by the whole quantity x minus 1. So 2 times 1 and 2 times negative x. So we'll get 2 raised to the 2 minus 2x equals 2 to the 3rd. So now the point here is that if our bases are the same, then we can set these exponents equal to each other. So we have 2 minus 2x equals 3, and I can just, solve that with basic algebra here. So subtract 2 from both sides, and get 1 over here, divide by negative 2, and I get x equals negative 1/2. Okay, here's our last example. Again, this one is a solve. And we want to get like bases. So we already have a base of 3 on the left-hand side, so I want to get a base of 3 on the right-hand side too. So I have 3 to the negative x plus 5 equals, I'm going to rewrite 9 as 3 squared. So then what I really have is 3 to the negative x plus 5 is equal to, again, if I just multiply the 2 and the 4x, that's 8x, so 3 to the 8x. Once my bases are equal, I can set my exponents equal to each other. So I get negative x plus 5 equals 8x, and then I can just solve this basic algebra here. So distribute my negative, add x to both sides, so I'll get 9x over here, and then divide by 9. So x is negative 5/9. All right, that's all we got in lesson. This is 10.2, so go ahead and check Schoology for homework.